Okay, there's one quick thing I want to mention, which will be kind of a sneak preview of the next homework for you. So when we looked at the pluck string, we saw that we were looking for this profile, which we call an exponential profile. The idea is that the high frequencies die out more quickly than low frequencies, and because generally the higher the modulation index, the more harmonics we have, as the modulation index goes down, we do lose those higher harmonics earlier. Okay, so this is called the exponential profile. This is not the only profile that you can do. So if we go back to Chowning's paper, what we see is he actually has a bunch of other suggestions, including the exponential. And actually, you can use the exponential for drums as well, it turns out. You just have to have different frequency ratios than we used. There's other kind of drums too, so you don't have to have exponential. You can have this linear drop-off. Okay, and then there's these. But here's another common one that you'll see. This is called the Adsr model for timbre. So we have attack, decay, sustain, release, Adsr. So this one is particularly apt for breath. And the idea is when you first go to blow into whatever horn it is, there's this initial attack and then a quick little decay, and then you hit your steady state, the sustain, as long as you're blowing in there. Then once you release, it'll drop off. And so actually it turns out if we multiply the modulation index by this amount, if the modulation index is proportional to this curve over time, we'll have things that sound like brass. So let me show you an example that I made. If I can dig it up here. Okay, so here we go. Okay, so I'm not totally done. It's one of my favorite pieces of all time by Mussorgsky, called Pictures at an Exhibition. It's by a Russian composer about visiting Paris and looking through art museums. And that's the promenade when the observer is walking between pictures. So pictures at an exhibition. So there's this famous trumpet part in the promenade. If it's actually it was written for piano, but when it's performed by an orchestra, the trumpet would play that part. And so that was my best attempt at using FM synthesis to come up with something that sounded like brass. So I'll provide this, as a text file in the format that we've had so far, and you can see if you can get it. I will finish a little more of the tune there for the promenade, but that's that. Now I don't want to say too much more because it'll be your task in the assignment to come up with some of these examples. So you'll make a method that makes this kind of shape, and you'll use that as your modulation index, and then I'll probably have you do at least one for drums and maybe something else. So I don't want to give it all away right now, but we'll get to it. Okay, but there is one more tool that I need to teach you, and so just take a moment to take a breath. So because we're kind of done all the music knowledge for this module, but there's something I need to teach you in Python that's going to make our code much more elegant. We're almost going to be able to, like a synth, we're almost going to be able to plug things in and out. So we'll kind of be able to plug in our different envelopes, called an envelope here, swap those in and out, swap in different parameters for the notes in a very elegant way. All right, so we're going to talk about that next.